Welcome to the Deep Dive, the show where we cut through the noise, sift through sources, and really try to pull out those key insights for you. Today we're tackling a big one. It's everywhere, it's changing things fast. Artificial intelligence, AI.
Yep, AI. And it's funny, you probably interact with it constantly.
That's just it. Think about the last few hours. Did you ask your phone something? Scroll a feed? Or maybe, get sucked into another Netflix recommendation?
Happens to the best of us.
Right. And in all those moments, that was AI working behind the scenes. Often you don't even give it a second thought.
Mm-hmm.
But how does that magic actually happen? How does a machine learn your voice or figure out the perfect show for you or even manage a pretty decent chat?
Yeah.
So our mission today, pull back that curtain. We want to explore how AI really works, how it learns, makes decisions, the whole deal. But in plain English, no PhD required here.
Absolutely. And we can maybe keep coming back to that Netflix example, right? How does it seem to know what you want to watch next?
Exactly. Let's use that. So first things first, foundational stuff. What even is artificial intelligence? At its heart,
Okay, fundamentally, it's a part of computer science. The whole goal is building machines that can do stuff that, well, usually needs human intelligence.
stuff like what specifically?
Oh, a whole range. Learning from experience is a big one. Recognizing things, objects, faces, your voice, understanding language like we're doing now, and crucially, making decisions based on information.
Okay, so it's not just one single thing called AI. There are levels, right?
Yeah.
Different stages.
Exactly. That's really important. What you're using day to day, that's what we call narrow AI, sometimes weak AI.
So Siri, Google Assistant, my spam filter,
Yeah.
Netflix.
Yep. All narrow AI. They're designed for one specific task. They can be brilliant at that one task, but that's it. They operate only within that narrow lane.
They're specialists.
Precisely. And that specialization is actually why they're so common now. They're incredibly useful for specific jobs, even if they can't, think broadly.
Gotcha. Then there's the next level, general AI.
Right. And that's pure science fiction for now. That would be an AI that could think, reason, understand, learn, basically any intellectual task a human can across the board.
Not something we need to worry about just yet then.
Not in the way it's often portrayed, no.
And beyond that, there's talk of superintelligent AI.
Yeah, that's the hypothetical endgame for some. AI vastly surpassing all human intelligence. It definitely gets people thinking, both excited and a bit nervous sometimes.
Understandably. So given we're mostly dealing with this narrow AI, this specialized AI, how is it already seemingly everywhere? What makes it tick?
Okay, so let's get under the hood. How does Netflix actually recommend that show? It starts with one thing, data.
Data, right. You hear that word thrown around a lot.
And for good reason. Every AI system needs data to learn. Vast amounts. Think of it like a baby learning about the world through senses. AI learns from data.
So for Netflix, that means what I watch.
Exactly. What you watch, what you don't watch, what you rate thumbs up or down, how long you watch something. Even when you watch certain types of shows. Billions of little signals.
Okay. And a self-driving car.
It learns from millions of hours of driving footage. Seeing roads, traffic, pedestrians, everything. A chatbot learns from millions, maybe billions of lines of human conversation.
And the quality of that data matters, right? Like if the data is messy or biased.
Hugely important. Garbage in, garbage out, as they say. Clean, diverse data is crucial. And bias in data, that's a massive challenge we need to talk about later. It means the AI can inherit our own biases.
Okay, so data is the foundation. What's next? What does something with the data?
That's where algorithms come in. You can think of algorithms as the recipes or the instruction manuals the AI uses. They're sets of rules, often mathematical models, that help the machine find patterns in all that data.
So not just rules like if this, then that. More complex.
Much more complex, usually. Imagine teaching an AI to recognize cats. You don't just list pointy ears, whiskers. The algorithm analyzes millions of cat pictures and starts identifying subtle, recurring features. The curve of a shape, textures, proportions. It learns the pattern of catness from the data itself.
Okay, data feeds algorithms. Then what? How does it actually learn?
That process is called training a model. This is where the AI really starts to, learn. It uses the algorithm to make predictions based on the data.
Like, will this user like this movie?
Exactly. And then it checks this prediction against reality. Did the user actually watch it, like it? If the prediction was wrong, the AI adjusts its internal settings, these things called weights.
Weights, like turning dials.
That's a great analogy. Imagine a complex mixing board with tons of dials. Each weight is a dial controlling how much importance a certain piece of information gets. When the AI gets something wrong, it slightly turns those dials.
Fine.
Precisely. Trial and error. It tries, gets feedback, adjusts, tries again, over and over, millions of times. And each time, it hopefully gets a little bit better, a little more accurate. That whole iterative process, that's machine learning.
Machine learning. Okay, I've definitely heard that term.
And this leads us to some of the more advanced stuff, like what powers ChatGPT or really good facial recognition, neural networks, and deep learning.
Sounds complex. Inspired by the brain, right?
Loosely inspired, yes. A neural network is like a web of interconnected nodes, kind of like neurons. Each connection has one of those weights or dials we talked about, determining how signals pass through the network.
And deep learning just means lots of layers.
Essentially, yes. Many layers of these nodes stacked on top of each other, hence deep. This allows the network to learn patterns at different levels of abstraction.
How so?
Well, the first layer might learn to recognize simple edges or colors from the data. The next layer combines those edges into simple shapes. The layer after that combines shapes into objects like eyes or a nose and so on.
Until it can recognize a whole face or understand the meaning of a sentence.
Exactly. That layered hierarchical learning is what makes deep learning so powerful for complex tasks like language and vision. It's behind a lot of the AI advancements you see today.
Okay, so we have data, algorithms, training, neural networks, but you mentioned different ways AI learns. What are those?
Right, there are a few main strategies. The first is probably the most common, called supervised learning.
Supervised, like having a teacher.
Pretty much. You give the AI data that's already labeled with the correct answer, like flashcards. Here are thousands of pictures labeled dog and thousands labeled not dog.
So it learns by example.
Exactly. It learns the relationship between the input, the picture, and the correct output, the label dog. Then, when it sees a new picture, it can classify it based on what it learned. Netflix might use this by looking at viewing history labeled with user ratings.
Makes sense. What else?
Then you have unsupervised learning. Here, you give the AI data with no labels. You just dump the data on it and ask it to find patterns or structures on its own.
How does that work?
Well, imagine giving Netflix tons of user viewing data without any extra info. An unsupervised algorithm might automatically discover groups or clusters of users who watch similar things. It finds the hidden patterns without being told what to look for.
So it could identify, say, sci-fi fans who also like documentaries.
Potentially, yes.
Right.
It groups things based on similarities it detects in the data itself.
Interesting. And the third type?
Reinforcement learning. This one is quite different. It's all about trial and error, learning through rewards and punishments.
Like training a pet?
Sort of. The AI takes an action in an environment. If the action leads towards a desired goal, it gets a reward, a positive signal. If it does something unhelpful or wrong, it gets a penalty.
Ah, so it learns by trying things and seeing what works.
Precisely. This is huge in game playing. Think of AIs learning to play chess or Go. AlphaGo learned this way. It's also used a lot in robotics, teaching robots to walk or manipulate objects, and in optimizing things like self-driving car decisions.
Wow. Okay, so supervised, unsupervised, reinforcement, different tools for different learning jobs.
Yeah, and sometimes they're even used together. But these are the core ways an AI goes from raw data to actually performing intelligent tasks, those aha moments for the machine, if you will.
Okay, let's pivot a bit. We know how it learns now, roughly. Where are we actually seeing this AI in action every day, beyond just Netflix?
Oh, it's truly woven into the fabric of daily life now. We mentioned recommendation engines, Netflix, Spotify, YouTube, Amazon. They all use AI to predict what you'll like.
Yeah, sometimes scarily well.
They analyze your behavior, compare it to millions of others, and find patterns to suggest the next song, video, or product.
And voice assistants? Alexa, Siri.
Definitely AI. They use natural language processing, or NLP, which is a big field within AI, to understand what you're saying, the intent behind your words, and then generate a relevant response.
What about scrolling through social media?
AI is all over that. Your social media feed is curated by AI algorithms deciding what posts to show you and what order to keep you engaged. AI also helps filter spam, hate speech, and suggests people you might know.
Right. And it's moving beyond just screens, isn't it?
Right.
Into things like healthcare.
Absolutely. Healthcare is a huge area. AI is being used to analyze medical images, X-rays, CT scans, MRIs to help doctors detect diseases like cancer or diabetic retinopathy, sometimes even earlier or more accurately than humans alone.
That's incredible potential.
It is. And in finance, AI is constantly working behind the scenes, detecting fraudulent transactions, assessing credit risk, and performing high-frequency automated trading.
And the big one everyone talks about, self-driving cars.
Yeah, companies like Tesla, Waymo, Cruise, they rely heavily on deep learning and other AI techniques for everything. Seeing the road, identifying pedestrians and other cars, obeying traffic laws, navigating, it's an incredibly complex AI challenge.
So it's not just future tech, it's here, now, doing real things.
Exactly. These aren't science fiction concepts anymore. They are practical tools and systems impacting how we live, work, and interact every single day.
With AI being so powerful and, well, kind of mysterious sometimes, it's no surprise there are misconceptions flying around. Maybe we should bust a few myths.
Good idea. There are definitely some common ones.
Like the idea that AI is conscious, that it thinks and feels like we do.
Right, that's a big one, and it's just not true. Current AI doesn't have consciousness, self-awareness, feelings, or intentions. It's pattern matching and prediction on a massive scale. It processes inputs, generates outputs based on its training. It doesn't understand in the human sense.
So it's a tool, not a mind.
A very sophisticated tool, but yes, another myth. AI will take over the world, the whole Skynet scenario.
Yeah, you hear that a lot.
Again, that's not really reflective of where AI is or how it's built. AI isn't one single entity. It's a collection of different systems designed by humans for specific purposes. We control its goals and deployment. While its power needs careful management, the idea of it spontaneously developing its own malevolent goals is, well, it's movie stuff for now.
Okay, good to know. What about accuracy? People assume machines are perfect, right? AI is 100% accurate.
Definitely not true. AI systems are only as good as the data they're trained on. If the data has errors, is incomplete, or reflects historical biases.
Then the AI will make mistakes or biased decisions.
Exactly. It can inherit and even amplify human flaws present in the data. So accuracy is always a context-dependent thing, and perfection is rarely achievable. They make mistakes.
That's really crucial to remember. It's not magic. It's based on data, flaws, and all.
And thinking critically about how AI actually works versus how it might be hyped or portrayed is really important for everyone. Understanding the limits is key.
Absolutely. And that brings us naturally to the ethical side of things. Because with this much power, there are definitely big questions, right?
Huge questions, ones we're grappling with right now as a society.
Like the bias issue you just touched on. Can you expand on that?
Sure. If an AI is trained primarily on data from one demographic group, it might perform poorly for other groups. Or if it's trained on historical data that reflects past discrimination, say, in hiring or loan applications, the AI might learn to replicate those discriminatory patterns, even if that wasn't the intention.
So it can accidentally bake in unfairness.
Yes. And that's a major concern in areas like hiring tools, facial recognition accuracy across different ethnicities, and even predictive policing systems. Making AI fair is a huge ongoing challenge.
What about privacy? All that data collection we talked about.
That's another big one. AI models, especially large ones, need vast amounts of data. Sometimes this includes personal sensitive information. There's always a risk. How is that data stored? Secured. Could the model inadvertently reveal private information it was trained on? It requires really careful handling and strong privacy protections.
Yeah, I can see that. And the elephant in the room for many people, job automation. Will AI take all our jobs?
It's definitely changing the job landscape, no doubt about it. Some tasks, particularly repetitive or data-intensive ones, are being automated. So yes, some roles might decrease or disappear, but it's also creating new jobs, roles managing AI systems, developing AI, ensuring ethical AI use, and it often shifts the focus of existing jobs towards skills that AI isn't good at, things like complex strategy, creativity, emotional intelligence, nuanced communication. It's more of a transformation than just replacement, though the transition can be difficult for sure.
So, a complex picture, not just doom and gloom.
Not at all. But it highlights why we absolutely need thoughtful development. We need ethical guidelines, transparency about how these systems work, and clear accountability when things go wrong. We need to build AI responsibly.
Looking ahead then, putting aside the scary stuff for a moment, what's the exciting potential? Where could AI take us?
The possibilities are pretty amazing, honestly. Think about personalized education AI tutors adapting instantly to how each student learns best.
Wow, that'd be game-changing.
Or smarter cities, optimizing traffic flow, energy use, public safety. making urban living more efficient and sustainable. AI is also accelerating scientific discovery, finding patterns in complex data that humans might miss, leading to breakthroughs in medicine, climate science, materials.
And creativity, does it have a role there?
Absolutely. We're already seeing AI as a co-creative tool, helping artists generate ideas, musicians compose new melodies, writers overcome block. It's becoming a collaborator, augmenting human creativity rather than just replacing it.
So a future where AI helps us solve big problems and be more creative.
That's the optimistic vision, yes. And it's a big but getting there requires us to be deliberate. We need good regulation. We need to ensure fairness is baked in, and we need to make sure the benefits are shared broadly. That access isn't just for a privileged few. The goal should be AI that genuinely benefits all of humanity.
That feels like a good place to start wrapping up. We've covered a lot, from what AI is, the different levels, to the core mechanics like data and algorithms,
The different ways it learns, like supervised and reinforcement learning.
all the way to where you see it every day. Netflix, your phone, healthcare, and the big ethical questions we need to address. Hopefully you feel like you have a much better handle now on how this powerful technology actually works. You know a bit more about that Netflix magic.
So here's something to think about. Now that you understand a bit more about the building blocks, the data dependency, the algorithms, the learning methods, the limitations, how might that change how you look at the AI you use? Could you use that understanding to innovate or just to be a more critical user of technology every day?
That's a great question to leave folks with. If this deep dive helped clear things up or sparked your curiosity, maybe share it with someone else who's wondering about AI. Let us know what other topics you'd like us to explore in a future deep dive. We always appreciate your suggestions. Until next time, stay curious.